All right, boys and girls, thank you so much for coming today. This is really going to be awesome. We have a privilege to have a real software engineer work with our club today. Mr. Candelas is a software engineer. He programs professionally, and he's going to continue our side scroller and kind of walk us through some of the next steps to allow our side scroller to have the player, I think, throw an apple.
Yes.
So guys, let's give Mr. Candelas a big Northridge welcome.
So your cat has no way of defending himself. So it would be nice to be able to throw something at him. So we're gonna make something. We're gonna to go through the process of making something where you can throw something at the cat or throw something at your enemy. And so one of the things that I wanted to discuss today was the concept of a flowchart, where you kind of express what you need to do on pieces of on paper through short symbols to try and straighten out in your head what it is that you're trying to do. So why don't we start with when you want to throw something, you have to push a key, right?
Yes.
So we go ahead and start, which is the start, and this is how you usually start a flowchart. And we would need what to determine what direction we need to do. We'll go. What do we need? Yes?
We need to make it go towards the enemy.
True. But does it always have to go toward the enemy, or should it go a different way? What should we base our direction on? Yes? Yes.
Whichever direction the cat's facing.
Very good. Okay. Now, how do we keep track of that? Can I get Norm?
Well, we can use some sensors or variables.
Yes, we can. We can. Yes, Moti?
There's a direction.
Yes, there is. Very good. Now, so one of the things we would need to check is to check to see if there's a direction. So yes, we would need a variable to track our direction. Oops. Sprite direction ref, which I've tried to put something that tells you what it is that it does. So this is the direction, and it's a reference of which way it was going. So some of the things you can say in here is, like, say for example, if sprite direction is this, then yes, like set another variable, direction of apple, and say that more or less equals 1. And then if not, and I know this is probably very cryptic now that I think of it, if sprite your ref is negative 90, and if that's a yes, then set the direction of apple to -1. And all this is going to be in your jump. So you can use things like this to represent what it is that you need to do when you need to come up with a way of doing it in code. Now, as Moti said, we need another variable. Okay, but to answer your question, so you have your enemy, and you have to find your height and how low your enemy is, and then you have the apple. And it's got a height also. So you have to find out where these two collide. And putting that into Scratch is a little difficult and takes quite a bit of time. And maybe next year I'll have something like that. But for now, Let me pick this down again. Let me go back to this. So first, you need another variable also to track your height of your sprite. And why? Oh, can anybody tell me why? Norm?
So you can put the apple right on the player instead of it being in a random place.
Yeah, that's part of it. And also, say for when you're jumping, it doesn't make sense for the apple to start from somewhere else. It has to come from where the cat is. So, go ahead and turn your screens on.
Oh, they're right.
And let's make a variable. And we're going to make two. And they're going to be global. So let's call it sprite underscore yref. This time I'll use the correct marker. Okay. That's what it is. Oh wait, I'm sorry. Let me make it match. Right, underscore y ref. Okay, and let's make another one and call it sprite ref. Okay, now when you guys are done, tell me. Click make a variable, and you have to make it for all sprites. So. Sprite y ref, and we'll make another one also for all sprites. I call it sprite dir ref, and that'll track our direction. Okay, so now, can anybody tell me when we need to update these variables? Yes?
Every time the apple hits the enemy.
Well, yes, but when we're starting to throw it. So because we need to tell the apple where to throw from. Yes, Walter?
To start from the cat.
Yes, we start from the cat, but we need to update every time we move the cat. So, in a sense, we have to make sure we set these variables when every time we loop through our code that moves the cat to the left and the right. And we need to do that so we know this direction and we know the height, where it is relative to where we are next to the ground. So, one of the things what you could do is at the end of the loops, if you take a look at this area right here where my mouse is pointing, right here, we can go ahead and we can use our set data and we can set the direction. It tracks the direction. So what we do is set sprite dir ref to the direction. Then we also have to set the height. And if you go over in the motion, we also have a y position. And that tracks the position of the cat. So then you set the sprite direction ref to the y position. And then that will constantly update as you move the cat around to sprite dir ref. And y, the y position, you use that to set the sprite y ref. Okay. Now, the way I found out that I had made a mistake is if you look on your screen where the cat is, you can see all your variables moving. Now, if you go up and down the little mountain, you can see how the sprite Y ref changes. Everybody see that? And the sprite direction reference also changes. So now we go back and we're going to work on our apple. Okay, everybody ready to go to their apple?
Yeah.
As you can see, this is the apple code, so we're going to go and go through it.
I'm so sorry.
Now, well, do we need to start with our apple hidden or viewable?
Hidden so it doesn't show up on the cat.
Correct, because when you start scratch, it always puts everything on the screen for you. So, what we're going to need to do is, I'm going to start over here. Have another little small flow chart. When the little green flag, let's do that for the flag. Is clicked. One of the things we're going to do is hide it. So, from there, you already know you need two things. You need an event to track when you hit the flag, and also your next code statement is going to be hide the apple. So, does anybody know how to do that? Yes?
You hit events, grab a when green flag click, and then you go to looks and get hide.
Okay, very good. Let's all do that on your sprite with the apple, or on your apple sprite, I should say. From here, we know we needed an if statement to say if sprite direction ref is 90 degrees, to make sure we set another variable that we're going to need to tell which way the apple is going. So, let's go ahead and make another variable and call that dir of apple. So we have another one called that if we go back and look at our flowchart and I want to demonstrate how you can see this here. So if sprite direct is equal to 90, then we're going to set our variable dir of apple to 1. So go ahead and add this portion of code. The cat, we had created another variable and we called it sprite y ref. So we need to set our y. And why do we need to set this here? What's he?
So collide with the end.
No. Does anybody know? Do you know what the y represents here? What that y is?
The height.
The height of what?
The apple.
Very good. Yes. So it has to match the height of the sprite, whether he's up here on the mountain, or if he's down here, or if he was jumping, if he's in the air. Because if he's up here and the apple comes out down here, that doesn't make for a very good game, right? Okay. So I added a little sound to this. So I told it to play the fairy dust. So if you want, we can add this or not. So we'll quickly move past that. But it's nice to have a little bit of sound. And after that, we need to show it. Okay, has everybody got the show? Okay. So this, okay. So now that we have the direction of our apple and our position, how do we make it move? What do we need to make it move? Yes?
The x-axis.
Yes. We're gonna need to move in the x direction. But what do we control that with? What did you control your movement of the cat with? Yes?
The left and right arrows.
Yes, but what did you have in your code to move the loop? Yes?
Scroll X?
No. Moti? Take a guess. What happens when you have to do something over and over and over again? Whoa! All at once. That didn't quite work out. Somebody said a repeat loop. Yes, that's true. Now, does anybody know how many times you have to repeat to get to the end of the screen? You do? Yes.
30 times.
Why 30?
Because
And I know you saw that in the code.
30 because
I have no clue.
Because that's the scroll X length. 30.
You're getting closer. In all truthfulness, it was a guess. And it just happened to be how many times I have to loop given the amount I move every loop to get it off the screen. So, that being said, let's go ahead and do this part right here, do the repeat loop. And I'll tell you a little bit about it. There it is. Okay, so now we have our cat, and we go around, and we can fire the apple this way, or we can fire the apple that way, and we can get on our mountain, and the height always matches, and we're okay. There's something else that I wanted to show you guys that's pretty cool. So if I can have you all turn your screens off for a second. It's something that I was working on that I wanted to show you, but it turned out to be very, very complicated. That does this.
Oh, I see.
that's a ridiculous.
Yes, you can get the matrix jump or bionic jump. Okay. Let you do something that otherwise would look like all this, which we call spaghetti in software land. So, with math, I was able to mimic the jump of why math matters. There's a function called sine, and it takes degrees. And what happens is, I'll just put that in this. From 0 to 90, it gives you this. Now, with a little bit of math, that's what gives me the jump. As you see, that's an arc. So I don't have to go and say, okay, move this much around, much over, move this 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 much over, and keep going.
Hard coded.
And put it in code where I can just run a loop and just get the answer. So this is why math matters. If anybody has any questions of this code, we can ask right now and use up the rest of our time. Does anybody have any questions? Yes?
Did you have to make another variable to make it?
There's quite a few variables in here. And the reason that is because you do have, because of the math and also for the direction, and also since it makes clones of themselves, you have to have variables to put the clone in the new position without having it move the other clone. So that's why it has a lot of variables. But let's go full screen. And
All right, guys,
There
let's
you
give
go.
Mr. Candelas a big hand.